Go. What do we have here? We have part 4 of Learn OS++ by example. And underneath we have a link of where the video can be found on my webpage. In the past we've spoken about cuboids and how they can be created from any one of these points. Also, we've got the midpoints, but I haven't displayed them because there's just too many of them. Now, rather than going through and doing all the other primaries, which would be cone, cylinders, and spheres, which can also be created from individual points, as shown, and all the little midpoints, what I want to do is I want to do a project, and I'm going to do a coffee spoon with the idea that I can wake up in the morning, 1 coffee spoon of coffee in the coffee pot, job done. The great thing about this particular project is we have a cuboid, in this case a rounded cuboid, and we have a sphere, and we have a negative cone. And in this way I want to show all of the different attributes and how they fit together with OS++. So let's go. The download. Point your browser at os++.org and click this icon here. Hopefully you should get a file like this. Run it through an archiver, pkzip, whatever, and hit extract. And you should get 2 files, the OS++ root and a welcome message. I'm not interested in the welcome message. Let's go into the OS++ root. Job done. The setup. The only files that actually matter in OS++ are the files in zlib. Everything else is fluff. Examples, text, we don't need it, so let's get rid of it. Got a subdirectory here which is also full of examples, we don't need it, get rid of it. We've also got project template. I'm going to rename that to project coffee, and we can go inside there. So here's our new project coffee. We have 3 different templates. Template number 1, template blank, is the minimum required to get OS++ running. Don't need it. Template 3 or template verbose is everything plus the kitchen sink. Don't need it. Template minimal is a cross between the two, a halfway house. I'm going to rename that to coffee spoon. We can spell. Okay, and we're going to call it version 1.00. Why am I calling it version 1.00? Well, the first model is going to be what I call a logical model, without any compromise to the 3D printer or the slicer. So this is just going to be a coffee spoon. All right, let's open this up with openscad and see what we've got. All right, I'm going to press F5, and this gives us the example or the template. If you look closely, you can see that we've got a primary, which is a cuboid, we've got a cone, or a pointy cone as I like to call it, and a sphere. So this is just an example of all 3 primaries, the simplest primaries we've got. Right. All very nice and very, very pretty, but it looks nothing like a spoon, so we need to make some changes. Let's run through the different things that we need to do. The first thing we need to do is a declaration. Is this a professional piece of code or is this an amateur piece of code? Well, I'm going to say this is an amateur, having some fun here. The next block is simply the OS++ framework. We need that, otherwise it doesn't work. So we leave that alone. The next block is a set of variables. This is the primaries. Each primary is represented by a single line. You can see that the cuboid refers to this cuboid. And if I actually simplify the data type, you can see that the cuboid is 10, 20, 30, referring to x is 10, y is 20, and z is 30. The cone, which is at the top, that's in the z-axis. I could change it to the y-axis. You can see that it spins round. All very good, exciting. But I actually want it in the z-axis. We can set it, this is the length, so if I click to 30, slightly bigger. 0 is the bottom circle, so if I make that 10, we now have cylinder. We make the top 5. We now got another cylinder. And then the last one is sphere in cone. And as a result, if we make it bigger, see, woo, maybe it's a bit too big. That's a little bit better. Okay. What I'm going to do is I'm going to rem them out. And the reason I'm going to rem them out rather than delete them is because I'm going to use them as an example. So I'll just copy and then copy, paste, and then modify. The next block of code is now a standard resolution, just tells the system what sort of resolution spheres and cones are going to be. And the last bit is simply calling the module, and the module's main. So what I'm going to do is rem it all out. And the reason I'm remming it out rather than deleting is that I can copy, paste, modify rather than typing it in from scratch, because that's going to be full of bugs. Okay, so if I hit F5 now, hopefully we don't get anything up here, and that's correct. We still get a whole load of guff here. I have a quick squizzle at that. Show you what I've got. Just putting it here so that you can actually see it. So the very first line says that, hello, you're using OS++, and it tells you its loader. It loads up the 3 primaries, libraries, one's cone, one's cuboid, one's sphere. It then loads up the math libraries. That's something I'm working on right now. And the last bit is it loads up add-ons, which are basically third-party pieces of code. So, for example, stuff from Thingiverse or someone else has written or something that you've written, you can just put it in there and away we go. I don't want all that information. I think of it as light pollution. So if I quickly hit F5, you can see it still comes up. But if I unrem this particular function OS++ hello equals off, I get nothing. So I think that's it. The setup is done. Excellent. Job done. Let's go to work. Let's do all the positive shapes that we need for our object. So let's get rid of this. Don't need that. So the first thing I need is a cuboid. So I'm going to take my cuboid and look through my example for a piece of code which looks like a cuboid. Excellent. I now have a cuboid. libcuboid comes from the cuboid. I'm going to generate it from 0, 0, 0, this point here, and have a cuboid body. Now, I'm not a monster, so what I will do is I will copy and paste this piece of code. Pop it in a function. Okay. Hit F5. Excellent. All worked beautifully. Right. There is a piece of code in here called red dot. Red dot is a third-party add-on that I wrote. It's not part of the library itself. It's a bit like a sniper's rifle in that it'll put a little dot to where we're pointing. So I push F5. There's my red dot. Okay. Now I want to move this red dot. So let's have a look at the code. That looks interesting. So I've just put a translate here in. Okay. All it does, it calls translate, and it runs this, nasty, nasty piece of code, which I'm just about to go through. So this code says, use the cuboid library, move using a Cartesian grid, and I want to go from 0, 0, 0 to 0, 0, 0. So hopefully nothing should happen, and it does. If I then say, let's make our handle more of a handle. So let's say, I don't know, 100, 10, by 5. Oops. Okay, so here's our handle. 100 long, y is 10, z is 5. And you can see that we're located right there. So I want to move from 0, 0, 0, which is that point there, to 1/10 of the way along in the x. This is x, and I've said 1. And as you can see, I moved 10% along. 20%, 30%, and so on. So this point is 9/10 of the way along. Wouldn't it be great if I could get that, just that last little bit along? L for last, and we're right at the corner. So a sniper is now pointing at the last bit of cuboid body. I actually want to move up here, so I need to move my red dot to the middle of y. And I could just say 5, or I could say middle. It's the same thing. Now I want to move to the top of z. So I simply say L, could say 5 if I wanted to. It's in the middle, but I actually want it at the top. Okay, now what I want to do is I want to put a sphere there. So if I look through my code, let's have a look at the sphere. We've got a sphere here. Where is our spheres? There you go. Sniper dot. So we're saying libsphere, the sphere, the library with spheres in it. We're going to render it using the Cartesian grid. And we're going to render it from the middle, where x is middle, y is middle, z is middle, I, that's the center of the sphere. And we're going to render sphere in cone using this CF5. Ta-da! Now the interesting thing is our red dot, or our sniper dot, has gone back to 0, 0, because it's generated its translate. And there is our positive spoon. Obviously, we're going to have to remove bits from it later, but that's the general gist. Okay, the next thing we need to do is we need to put a little hole here. And I'm going to do exactly the same process. So I need to move or translate So we need to translate through the cuboid using the Cartesian grid, and I want to go from 0, 0, 0 to 0, 0, 0. Hopefully nothing happens, the dot stays where it is. Now I want to move up. I want x to be the same, but I want to move to the middle of y. Let's go with the middle. Could use 5, could use m. Let's use 5. We're now 5/10 of the way in the middle, and I want to move up to the top in the z. Okay, now my next translate, I don't actually want it to be relative to this cuboid. I want it to be about here, and I want it to be a specific absolute translate. So what I'm going to say here is translate x is going to be 5, y is 5. Nothing happens. Awesome. So all I've done is I've created a variable called translate hull, data type of a translate. And I'm going to say here, Oops. There you go. You can see that my little red sniper dot is telling me that it's about there. Awesome. So we have a relative translate using the cuboid body, and then we have added to that an absolute translate using a variable I created above. And then we've got red dot. So I'm just going to put a space there to make it pretty. So what I need to do now is look for a lib cuboid. No, lib cone, wasn't it? Lib cone. Let's have a look through the example. Oh, look. So lib cone. I'm going to use the library known as cone. Render using the Cartesian grid, and I'm going to go cone on top. Hit F5, and it doesn't work. And why doesn't it work? Ah, that's because I haven't unrendered that. Ta-da! Right, that's the strangest hole I'm going to need. So the Z's in the right direction. Let's make the thickness 20, and I want a hole of, let's say, 5. There you go. So there's my cylinder pointing up in the Z direction. It's got a length of 20, and it's got a roundness of 5. Let's make it 6. Why not? Okay, F5 to make sure it all works. Awesome. Now, the problem here is I actually want it to be through the handle. So what I need to do, I think, is I need to generate it from the middle. Okay. And there we have our positive shape. Ah, no, we haven't. We've got a little bit more to do. So we've got the handle, we've got the bowl, and we've got the hole. I'm going to need to chop this sphere in half. So what I need is a cuboid, I think. Cuboid, copy, and I'm going to put it here. I'm going to say cuboid, bowl, and then say minus. Now, if I look here, here's my sphere. I'm going to say it's 15, 15, 15. Effectively the same size, oops, as my sphere over here. Okay. Neaten it all up a bit. So here's my object. Here's my render. And hit 5. Okay, so we're rendering it from this point here. Obviously that's not ideal. I want to render it all the way over here. Now, awesomely, I already have that translate ready to go. So you can see this translate here moves from here all the way to the middle of that sphere. All I need to do is copy it, pop it there. Okay, close but no cigar. You can see that the sphere is the cube is being generated from the correct place, but it's being generated from the 0, 0, 0. I need it to be middle, middle, middle. Oops, to be a capital. Nope, wrong place. This one here. Okay, that's no good. It actually needs to be up a bit. All right, so what have we got here? Got the handle, got the hole through the handle. We've got the bowl, and then we've chopped it out using a cuboid. Excellent. I think that's the positive side of the work done. Now what we need to do is we need to bring in all the negatives. Okay, job done for this part. The negatives. Right. What we need to do now is we need to put all of our positive code and all of our negative code into different blocks. So the first thing we need to do is we need to union all of those shapes into one. Okay, with F5 to make sure I've done it right. Excellent. So this whole block is now one shape. What we need to do now is we need to take stuff away from it. And we take stuff away with a difference. F5 to make sure it all works. Awesome. So the first thing I want to do is I want to take our hole and put it into the minor section. So let's just call this hole for nail. Now if I hit F5, our cone has disappeared, leaving a nice hole. Awesome. I do the same for our F5. We now have half a sphere because we've removed the top. And we're beginning to look a little bit like a spoon. Now the thing about a spoon is it needs a center taken out. So I'm going to do, I'm going to take my code for my sphere. And hit F5. Now we have a bowl, which is very nice, but there's no way that we can ever 3D print that because it has a zero. We've basically got a sphere and we've removed a sphere. And it's exactly the same diameter, which means that that has a 0 length size. That's not going to 3D print. So what I'm going to do so this is the inside diameter of the bowl. And I'm going to call it 10. 5. Awesome. So it's beginning to look like a spoon. We no longer need our rod depth, so we can remove that as well. There you go. I think that's the negatives done. Right, let's tidy it up. But obviously we no longer need our little library, our database of the original template. We no longer need red dot. Hit F5, make sure it still works. Okay, and we need to change our variable names. So edit, find and replace. V. Think cuboid handle is the order of the day. Make sure it's all good. Hit replace all. Hit F5 to make sure it works. Good. Excellent. The next thing is cone on top. Change that to. I'm going to change you to cone hole, I think. Hole minus. I just say minus so I know that I'm talking about a negative shape. Have a quick look. I only actually use that once. There you go. Hit F5, make sure it still works. Awesome. Let's deal with the sphere name. So let's call that outside diameter. Well, I don't like the capital. Okay, OD, ID. For a quick look. Again, only one of them. There you go. Hit F5, still works. Right, everything is done. So I'm going to try and make it as obvious as possible of what is done with what. Right, okay. So there we go, hit F5, make sure it works. Right, so let's do some customization. So the handle is looking a little bit gruesome because it's got quite a, it's not a rounded cuboid. So I need to make it a rounded cuboid. Now let's give it a roundedness of, I don't know, 3. So it's still the same cuboid, but now it's rounded with 3. And that's looking a little bit better. Okay. What else can we change to make it more pretty? I think that's it, you know. I think we have quite a nice spoon there. Maybe we need to make it a little bit bigger. Let's make it 30. Might have to make our, oops. Maybe that. Okay, now we're cooking with gas. The handle. Let's make it a little bit longer. I think 120 would probably be better. Maybe a bit wider. Yep. A bit wider. Maybe a bit thinner. Yeah, a bit thinner. That's looking pretty good. Let's make the rounded bit a bit more rounded. There you go. I think we're done. Ta-da! The epilogue. So here's our spoon, and what a thing of beauty it is. As I've been going along, I've been saving the file, and so you have a situation where we have 1, 2, 3, 4, 5 files. The first one is the setup. The second one is all the positive work. The third one is the negative work. The fourth one is the tidy, and that all culminates into the coffee spoon. If you want to download these files, you can find them at osplus.org, 2022 video, index.html, and it will be the 5th one along. That's it. I hope you've enjoyed it.